Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 class KSP1 are going to present our group assignment titled Hydrocarbon. These are my group members. My name is Muhammad Faiz Fahmi with my friends Muhammad Hanif, Nurul Fatihah, Farha Nasuha and Najah. We will proceed to the first question. Name and draw the structure of X, Y, Z and explain the answers. The first one is hydrocarbon X, which is 2-methyl-2-pentene. It is an alkene instead of cyclohexane because it can undergo hydrogenation process to form an alkane, since the presence of the double bond between two carbon atoms in the compound X. The next one is the structure of Y, which is 2-methyl-pentan-2-tridiol. Y is an organic compound that contains two hydroxyl groups bonded to two adjacent carbon atoms. This is the product of the oxidation of compound X, 2-methyl-2-pentene, with cool, dilute, and basic potassium manganate solution. The last one is the structure of Z, named propanol. The alkene X, which is 2-methyl-2-pentene, is a 6-carbon hydrocarbon, which can undergo oxidation process with hot, concentrated, and acidic potassium manganate solution to form two products with 3 carbon atoms. The first one is the carboxylic acid, named propanoic acid, and the other one is the ketone Z, which is named propanol.
Next, we go to the second question. Write the equations and state the difference of observation for the reaction of X with cool dilute alkaline potassium permanganate and in hot acidic and concentrated condition. As we have learned in the lecture, potassium permanganate in base can be used to oxidize the alkenes to 1,2-diols, which is glycols. This reaction is called Bayer's test. It can serve as a reaction to detect the presence of carbon-carbon double bonds. So in this reaction, we already know that X is 2-methyl-2-pentene. When 2-methyl-2-pentene undergoes oxidation using basic, cool, and dilute potassium permanganate, it forms 2-methyl-pentan-2,3-diol and also manganese oxide. So the observation for this reaction is purple color of potassium permanganate is decolorized and brown precipitate of manganese oxide is formed. For the oxidation of 2-methyl-2-pentene using hot acidic and concentrated potassium permanganate, the products formed are propanol and propanol. Next, the aldehyde, which is propanol, will undergo further oxidation because there is the presence of strong oxidizing agent, which is concentrated potassium permanganate. For the further oxidation of propanol, it will form a propanoic acid. So, the final product of these reactions are propanol and propanoic acid. The observation for this reaction is purple color of potassium permanganate will turn to colorless.
So let us proceed to the next part of the question where hydrocarbon X reacts with hydrogen bromide in the presence of hydrogen peroxide. So based on the previous answers, we get to know that hydrocarbon X is actually 2-methyl-2-pentene, which is an alkene. So as we all learned before, the reaction of alkene with hydrogen bromide in the presence of hydrogen peroxide is an electrophilic addition which obeys anti-Markov-Nikov rule. So based on anti-Markov-Nikov rule, the hydrogen from the electrophile, which is in our case is hydrogen bromide, will be attached to the doubly bonded carbon with lesser number of hydrogen. So if we take a look to the alkene 2-methyl-2-pentene, we can see that the second carbon has a lesser number of hydrogen compared to the third carbon. So, when 2-methyl-2-pentene is reacted with hydrogen bromide in the presence of hydrogen peroxide, which is the catalyst, the hydrogen from the hydrogen bromide will be attached to the second carbon, which yield a major product of 3-bromo-2-methylpentene. And this reaction also gives us a minor product of 2-bromo-2-methylpentene, which doesn't obey anti-Markovnikov rule. So the hydrogen from the hydrogen bromide will not be attached to the second carbon, which has a lesser number of hydrogen.
Moving on to the fourth part of our presentation, which is the mechanism of electrophilic addition of alkene. There are two steps involved in this mechanism, which is step 1, the addition of an electrophile, and step 2, the formation of product from the carbocation. Step 1, which is the addition of an electrophile. The double bond in the 2-methylpentene is the nucleophilic site, which is rich in electrons. So, it will attract the electrophiles from the hydrogen bromide, which is hydrogen ion. 2 electrons is taken from the double bond to H plus ion, results in H attached to carbon using the electrons it took from electrophilic site. This step is slow and produce carbocation as well as Br negative. Step 2, which is the formation of product from the carbocation. As we can see, Br negative is now the nucleophile and the carbocation becomes the electrophilic site. This time, Br will attach to the positively charged carbon. This step is fast and will produce a major product, which is 3-bromo-2-methylpentane.
For the last part in this presentation, we choose ginger plant for our inert component. In our research, we got to know that ginger plant has functional group of alkenes that contains carbon double bonds. Ginger plant also has been mentioned in Quran, Surah Al-Insan, ayat 17. A'udzu billahi minasyaitonir rajim. Wasqana fiha ka'san kana mizajuha zanjabila. Sadaqallahul azim. And they will be given to drink a cup of wine whose mixture is of ginger. One of the components in ginger is zinniberine, or its IPAC name is 2-methyl 5,6-methylhep 5-in 2-il cyclohexaone-1,3-diene. A sesquiterpene is found in the rhizome of Indonesian ginger, which is Zinnia officinum. This ginger contains carbon double bond as its functional group. A raw ginger composed of 79% of water, 18% of carbohydrate, 2% of protein, and only 1% of fat. In 100 grams of raw ginger, it will supply 333 kilojoules of food energy and contains moderate amount of vitamin B6 and the dietary minerals magnesium and manganese. Ginger is high in gingerol, which act as anti-inflammatory and has antioxidant properties. It will help in reduce the oxidative stress that resulted from an excess amount of free radicals in our body. Consequently, it can treat nausea such as morning sickness. According to a review of tough studies that included of 1,278 pregnant women, 1.1 until 1.5 grams only of ginger can help in reduce the symptom of nausea. And this is our references, which are book, websites, and Al-Quran. That's all from us. Thank you.